Here's a video for graphing polynomials. So this is a polynomial. It's just 1/4 or 1/8 x to the fourth. So I gave myself harder problems. I don't know why. And then plus 1/8. So that really sucks, but that's okay. So to make it easier on myself, I'll just factor out and basically multiply everything by 8. So if I multiply everything by 8, that means I'm just multiplying f of x by 8. And so then I would get x to the fourth minus 2x squared plus 1. So then it's something easier to deal with for my sake. You won't have a problem like that with fractions in there or whatever. So then I just need to take, and I need to find my x-intercepts, or right here, x and y-intercepts. Y-intercept is pretty easy. Find my asymptotes, which there's going to be none for polynomial. And then the critical points. So critical points, extrema, relative max, relative mean, they mean all the same thing. Okay. And then find out where it's increasing, decreasing, inflection points, concavity, that type of thing. So all that we're asked to do. Okay. So what I want to do here is I'm just going to focus on this just because I really don't want to do those fractions. And so I take my factors of my lead coefficient, which are 1, plus or minus 1, and then factors of my lead coefficient, I might have said that twice, factors of my constant over my lead coefficient. Divide each of those, and so my possibilities is plus or minus 1. Okay, so I'm finding my x-intercepts here. And so those are my possibilities. So I list my coefficients, 0 for x cubed, 0 for x, and then my constant 1. So I'll plug in 1, which is going to work. That's a 1. 1. 1, 1, 1, 1, 1, negative 1, negative 1, negative 1, negative 1, 0. That's a 1. Alright, I should make this video really long, huh? Just so then you have to watch the whole entire thing. Okay, 0 for the next one. 1's probably going to work again. It probably has a multiplicity. So 1, 1, 2, 2, 2, 2, 1, 1, 1, 0. Okay, so 1 did work again. And it's not going to work this time, so how about negative 1? So let's try negative 1, see if that works. But we are down to 3, so I could cab it, because the factors of 1 that add up to 2 is 1 plus 1. So negative 1 has another multiplicity. So 1, negative 1, 1, and negative 1, 0, and then negative 1 is going to work again. Negative 1, 0. So really I have x equals 1 and x equals negative 1. This just has, they both have the multiplicity of 2. Okay. So those are actually my x-intercepts. Okay. So I actually do have x-intercepts at 1 and at negative 1. As I wrote down those backwards, but 1 and negative 1. So there you go. So those are the x-intercepts. Y-intercept I can plug in 0 and for x and solve. So I'm doing this one. So really I'm just doing this problem. This one right here. So really I'm just erasing that, putting a 2 in front of that. So that's really what I'm doing here. Okay. Just to make it easier on myself. Okay. And then I can go ahead and plug in 0 for x and I get 1. So 0 for x, get 1. So there's my y-intercept. So I have my x-intercept and y-intercept. I have no asymptotes because it keeps on growing and growing and growing, whether I put in negative or whether I put in positive, right? Because when I put in negative number, I keep growing and growing and growing. And when I put it in a positive, I keep growing and growing and going. So now I need to see what's in between here, what's happening in between. So that's when we take our derivative. So 4x cubed minus 4x. And now I can factor out an x, so I get x 4x squared. I can take out a 4x. Why don't I just take out a 4 and an x? So when I take out the x, then that means one of them is 0, right? So I get x squared minus 1. And then I can factor that to x minus 1 and x plus 1. And so that means 0, 1, and negative 1. Those are all my extreme values, or critical points. And so I can put those on a number line. So now I'm going to start erasing stuff. So I put those on a number line, and I test into the derivative in between these, which is great, you know, because now I have to use a half. But I plug them into the derivative, which is right here. So I want to use factored form, because that's easier to test, because all I care about is positive and negatives. So I plug in a negative 2. That's negative. That's negative. And that's negative. 3 negatives is a negative. So to the left of negative 1, it's decreasing, which we can see it already is. And then in between here, I plug in a half, a negative a half, because I'm negative left of 0. So that's still going to be negative, that's going to be negative, and that's going to be positive. So I get a positive. So that means I'm increasing between negative 1 and 0. I'm increasing, so I'm going up here. And then after that, I am positive a half. So positive a half, so that is negative there, positive here, and positive here. So that is a negative, so I'm decreasing. So I'm going back down between 0 and 1. And then after 1, I can plug in 2. So I plug in 2, that's a positive, and that's a positive, so all positive. So I'm increasing, as we can see from the green arrow there. So that's kind of what my graph looks like. Now I do need to see where my maxes and mins are. And we can see, because I go from decreasing and increasing, that I have a relative minimum at negative 1. So my min is negative 1, 0, which is lucky because I already have that point down, so I know what the y value is. If I didn't have that point down, then I would need to plug that x into my original to figure out what it is. And I'm also going to have a relative min right here. And so that is at positive 1, 0. And then my relative max. And really, actually, these two on bottom minimums are actually absolute because they are the lowest, because I have to the 4th. However you spell absolute, I don't know. So I don't know if you're going to get the best quality of video here. 0, comma, what did I say? What do we plug in and get? 1. So I don't know if you're going to have best quality of video here, but you asked for it. So 0, 1. Okay. So those are my absolute minimums because it's to the 4th. And there's my max. So those are my critical numbers or my extrema, relative extrema. Now I have to do concave up and concave down to find my inflection points. So inflection points, I need to take the second derivative. So here's my first derivative, 4x cubed minus 4x. So 4x cubed minus 4x. So I'm going to take the derivative of that because this is the first derivative. So that's negative 12x squared minus 4. I can factor out another negative 4. I'm going to factor out a negative 4. Was it negative to begin with? No, it wasn't. That was silly. Okay, factor out a 4. And we get 4x, actually. And we get, no, we're not going to do 4x, jeez. See the quality? It's going downhill. So 3x squared minus 1. And that's not going to factor, so I have to use quadratic formula, or I can square root because I'm missing my b. So plus or minus root 3. So those are my values. So I don't know what that is on my. I have to figure that out on my calculator. So square root of 1 is just 1. So I divide 1 divided by square root of 3, and really don't know what that is. Because I'm using a silly calculator. Okay, so that is 0.58. So 0.58 and negative 0.58. So those are my values that I'm going to test. Negative 0.58 and positive 0.58, which is almost a half. So I want a number in between here and to the outside. So I can test negative 1 into the second derivative. So negative 1 into this, I'm squaring my x's, so they're automatically going to be positive. So a negative 1 squared is going to be positive 12, so that's going to be positive. And a positive 1 squared times 12 is going to be positive. And then plugging in 0, I get negative. So that means I'm concave up, concave down, and then concave up again. Okay, so that means I have an inflection point here and I have an inflection point here. So kind of the crappy thing is I have inflection points at those two values. So that means I need to find the y value. So that means I need to plug those two numbers in back into my original function, okay, in order to graph. All right, so negative 0.58. So somewhere about right here and somewhere about right there. So I need to find their y values, right? So here's my original. And so I'm going to enter in just like kind of like this on my calculator. I'm going to do parentheses, hit my fraction button, hit 1 over square root button, put in a 3 in here, square that number, type negative 2 times that same x. Oh, that's to the 4th, sorry. To the 4th, negative 2, same thing on this one. So I'm going to try to put it just like this into my calculator, and we'll come back. Okay, that took forever because I had to figure out how to use this calculator and switch the different modes. So it's going to be even longer video, and my kids aren't going to get any food tonight. So I get 0.4 repeating. So 0.4 is almost a half. So right below a half, somewhere down there should be my point. And when I plug in the negative, I'm going to get the same thing, right? Because it's to the 4th, which is going to turn that negative to positive. And it's squared, so it's going to turn that negative to positive, okay? All right, so then we know we're concave up, so this is going to help me graph. So we're concave up until this point, so we're graphing up like that, and then we're concave down in between those two, and then we're concave up again. Okay, so that's just going to help me graph. It doesn't quite like that one, but it's like that, something like that. So there you go. So I got my inflection points. So label those inflection points, 0.58 and 0.44, and then negative 0.58, 0.44. These x-intercepts 1, 0, negative 1, 0, and this y-intercept would be 0, 1. So there I have all my points labeled. I know where I'm concave up and concave down. I have that down at the bottom here. So you can say if you want to like concave up from negative infinity up until 0.58 or negative 0.58. And then I'm also concave up from positive 0.58. So positive 0.58 to positive infinity. And then I'm concave down from negative 0.58 to 0.58. Okay, and so there you go. There's how you graph polynomial function. Hopefully you like that and that made sense to you. And so here's a rational function. Okay, so I need vertical asymptotes, so set my denominator equal to 0. Subtract 2, so x equals negative 2. So there's my vertical asymptote, x equals negative 2. Then I need my horizontal. That's taking the degree of the top and the degree of the bottom. If they're the same, then it's just the coefficients. 1 divided by 1, so this is y equals 1. So y equals 1. Now, I can really just go ahead and plot points here, and I have it. But we need to find out where it's concave up and concave down and those inflection points. So we go ahead and take our derivative. So this is g, this is f. Derivative of f is 1 times the bottom minus the derivative of the bottom, which is 1 times the top, all over the bottom squared. We go ahead and set that equal to 0. I haven't found my x-intercepts yet, but I will. So those x's go away. So I have 2 over x plus 2 quantity squared. Okay. So on this one, and when I set my derivative equal to 0, there's no x's that are going to make this 0, right? Because I just have a 2 on the top. So there's no x's that I can test in the first derivative. So then what I can do is I can just test the vertical asymptote. So I plug that in, which is 2, not 0. So I test it to the left, and I plug in a number. Say, like, it's automatically going to be positive, right? So it's going to be positive. So we're increasing there. And I test the number to the right of that, and it's also going to be positive. Right, because I'm plugging a number, I'm going to square it, it's going to be positive. Okay, so that means I'm increasing. So probably graph it looks something probably like this, increasing and increasing. So something probably like that most likely is going to happen. Okay, so then I can go ahead and take the second derivative. Again, I kind of skipped the x-intercepts for now because they're really not too important on this one. You could still find them by setting the numerator equal to 0, and that will find them. So then I go ahead and, which you can go ahead and do real quick. So I'll throw this out of order, which is just 0, right? 0 for x. And I get a 0 for y. So my x-intercept is the same as my y-intercept. So there you go. All right, now I need to take the second derivative. Here's my first derivative, f prime of x. X plus 2 quantity squared. So take the derivative of the top, that's 0. 0 times anything is still going to be 0. And then minus the bottom, which is, so that's the derivative of the bottom. It's chain rule. And now I got to times that by the top, so which is another 2. So really it's just 4 over the bottom squared. So that's to the 4th, sorry. Okay. See, the quality of this video is just terrible. 4x minus 8 all over x plus 2 quantity to the 4th. Okay, so then I set that equal to 0. So again, I don't really care about the bottom because when I multiply both sides, this will kind of go away. So I'm just looking where the top is 0. So that's a negative 2, right, for x. So there is x equals negative 2. So x equals negative 2 would be, that's the second derivative. So x equals negative 2 makes the second derivative 0. So put that on a number line. This is going to find concave up and concave down. So I can plug in 0 and I can plug in, say, 3 and test those, see if I have concave up or concave down. Automatically the bottom is going to be positive because it's to the 4th, right? So plugging in 0 is going to just make a negative. Plugging in 3 is going to make a negative as well because that's a negative 4. 3 times that. Real quick. 3 will work, not 0, sorry, not 0, but negative 3. So positive 3, negative 3, say. So that's a positive, whatever, positive 12. So that's a positive, sorry. And this one will be negative. Okay, there we go, fixed it. So this is concave up before negative 2, and this is concave down. So that means, and we can kind of see that already. So negative 2, our graph is going up, right, increasing, and over here it's decreasing. Where did I get that point? 0, 0. That was from the original, right? Yeah, plugging in 0, I get 0, yeah. Okay, so I have that point. So what that tells me is a little bit something different, but that's okay. So now what I can do, I know where it's concave up and where it's concave down. So I'm concave up from negative infinity up into negative 2. Okay. And maybe I plotted this point wrong. Yeah, I didn't. That's why I did negative 2. And so you're probably wondering from the very beginning, but now I've already went through this video this far. So now I'm not going to go back and erase that and start a new video because I'm not going to start a new video. Negative 2. I'm sorry, but that's what you get when you rush me through it. No, that's all right. There we go. Okay, so it looks something like that. And so I know where it's concave up now, where it's concave down, and I can go ahead and plot some more points. So I can plug in negative 4 into the original. Negative 4 plus 2 is negative 4 over negative 2, which is positive 2. So up 2, 1, 2. So it's more like this and like that. So fix it a little bit. I already have this point, so that's enough points. That's all I need. So there you go. Sorry about that, putting it in 2 there when it should have been negative 2. You're probably saying that from the very beginning. What's he doing? Now you're confused. So there you go. There's 2 of them for you. That's all I'm going to do because it's already 20 minutes and it's a terrible video anyways. So you could go to graphing. I think it's labeled as pre-cal, and it's on stream and it's on YouTube. Pre-cal chapter 3, and I'll make sure it's public. Chapter 3, graphing, polynomials, and it says poly, and then it says and rationals. So that video is better, hopefully. The only thing that's different is taking this second derivative and first derivatives, right? And making sure you find those relatives, max and mins, and finding the concave up and concave down. Hopefully that helps you, and you're ready for your test tomorrow.